Hello, I am Matthew Temple, as you can see here. Question number 1 asks what the identity and purity is of the liquid obtained in Technique 1. We must determine its concentration in the unknown solution and discuss how I figured out its purity, identity, and concentration. To figure out the identity of unknown D, I first compared the vapor temperature during collection of the distillate, which was 56 to 60 degrees Celsius, to the boiling points of the four possible unknowns: acetone, isopropanol, methanol, and cyclohexane. The literature values for the boiling points of the four possibilities are 56.2, 82.4, 64.5, and 81 degrees Celsius respectively. After this comparison, I was able to eliminate isopropanol and cyclohexane as possibilities due to their boiling points being over 20 degrees Celsius higher than my vapor temperature. At this point, I expected the identity of unknown D to be acetone, as my vapor temperature was closest to the literature value for acetone. Since methanol and acetone have similar boiling points, though, I required further testing to concretely identify unknown D. For this further analysis, I obtained an IR spectrum of my distillate. The IR spectrum showed a strong sharp peak at 1707 reciprocal centimeters, corresponding perfectly with the ketone oxygen present in acetone. There was also no strong broad peak around the 3 to 3.5 thousand reciprocal centimeter region that would correspond to an OH bond stretch expected if methanol was present. I then compared my experimental IR spectrum to literature IR spectrums published for acetone, and the spectrums look pretty well identical. Now that I knew the identity of unknown D, I went on to determining the concentration of acetone in the original crude unknown D solution. I started with approximately 20 milliliters of crude unknown D solution and distilled 4.67 milliliters of acetone. Assuming my acetone has a high purity, the concentration of acetone in the crude unknown D solution would have been approximately 23%. Based on my adherence to careful distillation protocol, the vapor temperature, and my IR results, I conclude that my product likely has a high degree of purity. During the distillation process, my vapor temperature stayed fairly steady, with the temperature rising very slowly. I discarded the first drops of distillate collected before the temperature plateaued around 56 degrees Celsius and stopped collecting as the vapor temperature started to climb faster and up past 60 degrees Celsius. This rise in temperature likely indicated a change in vapor composition. Another supporting factor for the purity of my compound is that my vapor temperature was 56 to 60 degrees Celsius, which corresponds with the literature value of the boiling point of acetone, 56.2 degrees Celsius. My IR spectrum had no unexpected peaks that would correspond to food coloring, sodium chloride, or water, further confirming the purity of my acetone distillate. Question 2 asks, for technique 3, how would the RF values change if the eluent was changed to methanol? The RF values would increase if the eluent used was methanol instead of hexanes to ethyl acetate in a 1:3 ratio, because methanol is more polar and has a higher solubility for benzoic acid as well as ethyl 4-aminobenzoate. This means that methanol would carry these two compounds further up the plate than the less polar solvents hexanes and ethyl acetate. The methanol may actually in fact be too polar for this experiment, as the RF values were already approximately 0.53 and 0.65. Using methanol may have pushed the RF values up closer to 0.9 and or into an uninformative range, whereas the RF values obtained are just over 0.5 and are kind of in the butter zone. Question 3, we were assigned an unknown composition of three different compounds. we're supposed to assume that it's solid, 3 grams and homogeneous. My mixture contains sucrose, benzophenone, and 2-naphthoic acid. And basically, I would purify them all just by recrystallization. First, I would add water to the crude material to dissolve the sucrose while leaving behind the benzophenone and the 2-naphtholic acid. Sucrose readily dissolves in water at a rate of approximately 1 gram in 0.5 grams of water, whereas benzophenone and 2-naphthoic acid are basically insoluble in water. Then I would gravity filter out the undissolved benzophenone and 2-naphthoic acid and evaporate the water from the sucrose solution, which would leave us behind with some pure sucrose crystals. Then I would dissolve the 2-naphthoic acid in cold methanol and filter out the pure benzophenone solid to isolate the benzophenone. Then evaporate the methanol from the 2-naphthoic acid solution to leave behind the pure 2-naphthoic acid crystals. And then there you go. So basically my recrystallization will go like this. Since there's all these polar groups on the sucrose, there's lots of availability for hydrogen bonding, all kinds of allowing it to dissolve. Whereas benzophenone and the naphtholic acid have these big aromatic groups on blocking the access of the water molecules to be able to do much hydrogen bonding with them, giving them a very low solubility. The dipole moment for these two is also very weak. They're not as nearly as strongly polar as this. There's just these big hydrophobic groups here that'll block water. And then we use methanol to separate these two, as this is a bigger dipole, and so methanol can solvate this much easier than this. So once this is dissolved, then we simply just have to filter out the benzophenone because it will not be dissolved by the cold methanol. The recrystallization part of it works because once all of these are evaporated off and eliminated, there's no longer anything holding it into solution. Once there's no more water, we'll just have pure sugar left over. Question 4 was, what is the identity of the unknown assigned to you? And so after searching up the molecular weight, the melting point, and the percentage composition of the elements, I came up with my compound being 3-amino pentadionic acid. And other names for it, 3-amino glutaric acid or beta-glutamic acid. Found this on the Combined Chemical Dictionary. I have 2 primary sources, which wasn't very easy to find, but I did it. One's a little bit Chinese, but to be honest, most of the articles that are primary sources we either don't have access to or they're in a different language, so it makes it extremely challenging. And here are my 2 secondary sources. Question 5 is to arrange these boxes which describe the peer review process. As you can see here, I put some arrows. Obviously, first the scientists would have to collect the data, and then they would write the manuscript. Then they would get it peer reviewed and have feedback provided. They would edit it, and then once they are happy with it, they would submit it to the journal editor, and then the manuscript is either rejected due to not meeting the journal criteria, or if it meets the criteria, it's published. And then a whole bunch of citations.